And we have one last type of calculation to put into our notes, and this is pretty similar to the last one we did. So the last problem, we were trying to figure out what we needed to do to make a solution that had a particular pH. Here's another type of that problem. How much 5 molar HBr is needed in order to make 600 milliliters of HBr with a pH of 0.80. So let's think about what this problem is asking us. Because we know we have this target pH, what we're really trying to figure out is what H3O plus concentration do we need to get a pH of 0.8. And let's just start by solving that particular problem. Remember, our pH equation is negative log of H3O plus, but that's really not going to help us in this particular problem because we know the pH and we're trying to solve for H3O plus. So we can't use the equation in this form. We need to use it in the other form, the antilog. H3O plus equals 10 to the negative pH. 10 to the negative 0.80. The H3O plus concentration that we need is 6 point, oh, I forgot a negative sign. 10 to the negative 0.8. That's better. 1.16. That makes more sense than 6. So we need to make an HBr solution that has a concentration of 0.16. Now this is a little different than the KOH problem, because in the KOH problem, once we figured out our desired molarity, in the KOH problem, we had a particular volume that we were shooting for, and so we calculated what kind of mass of KOH we would need to get to that particular volume. In this problem, it's telling us that we do, again, have a particular volume that we're shooting for, but our supply, our source of HBr is another solution, it's a different solution. There's a really fast way to do this calculation. It's an equation that Gen Chem students never use enough, and then you need to rely on this equation because it is so helpful. M1V1 equals M2V2. In this problem, M1 is an initial molarity, and V1 is the volume of that particular solution with the initial molarity. And M2 is a final molarity, and V2 is the volume of that solution with the final molarity. We call this the dilution equation because we use it when we are doing a dilution. When we are, for example, taking a solution, one solution, with a particular concentration and figuring out what we need to get a less concentrated solution. In this problem that we're working on right now, our M1 is the initial molarity, 5.0 molar HBr. And V1 is what the question is asking us. It's asking us how much of that do we need. M2 is the molarity that we are trying to figure out, or that we need to make. So M2 is 0.16. That's what we calculated we needed in order to get the right pH. And V2 is what was given to us in the problem. Our goal is to make a 600 milliliter solution. When we're using the dilution equation, we can use any unit of volume that we want as long as we use the same unit consistently throughout the equation. So let's plug these into M1 V1 equals M2 V2. And we're trying to solve for V1. So we want to divide both sides by M1. And we get V1 equals M2 0.16 molar times V2 600 milliliters divided by M1 5.0 molar. Look at how those units cancel out, and the unit that we're going to be left with is milliliters. 0.16 times 600 divided by 5, we get 19.2 milliliters solution is needed.